Hello everyone. In this video, we're going to talk about starting with integrity constraint violation during transactions. When we work with tables that have foreign key constraints, it's important to understand how to insert data without causing violations. Let's consider the following person table where each person has a father and mother, both of which references other entities in the same person table. So you can see the create table person where we have all the attributes ID, name, mother, father, and then we have primary key as the ID, and then foreign key, two foreign keys, that is father and mother, that reference the person table itself. Each person's mother and father must already exist in the person table before the person can be inserted due to the foreign key constraint. This creates a circular problem when trying to insert a family where the parents haven't been inserted yet. So how to insert without violating constraint? There are two options. One way to handle this is to insert the father and mother record first. Then once the person are in the table, you can insert the person who references them. Another one is in some databases, or another approach is you can set it null. So if you set it null, then another option is to first insert the person with null values for father and mother, and then later update the record once parent records are inserted. That's the second approach. And then in some database systems, you can defer foreign key constraint checking until the end of a transaction. This allows you to insert all the records in any order, and the database will check the constraints only when the transaction is committed. Let's look at how the check constraints can include subqueries, allowing us to enforce complex condition. For example, we might want to ensure that the time slot ID in the section table corresponds to an existing time slot ID in the time slot table. So we have this check clause where check time slot ID in, select time slot ID from time slot. The check constraint ensures that every time slot ID in the section table matches a valid time slot ID in the time slot table. When is this checked? The condition is checked not only when inserting or modifying tuples in the section table, but also if the time slot relation changes. This ensures that the data remains consistent across both tables. Let's talk about assertions in SQL. An assertion is a rule or condition that we want the database to always satisfy. It is useful for enforcing more complex constraints that go beyond individual tables or rows. Examples of assertion: ensure total credits match for students. We can assert that the total credit attribute in the statement student relation must always equal to the sum of credits from courses that a student has successfully completed. And another example is prevent an instructor from teaching in two different classrooms at the same time. We can assert that no instructor teaches in two different classrooms using the same time slot within a semester. So the syntax of assertion, you write it like create assertion, then the assertion name, and then check the predicates. SQL provides several built-in data types to handle dates, times, and time intervals. The date type stores a calendar date in the format of YYYY, and then month, and then day. This example is 2005, and the month is 7, and day is 27. The time type stores the time of the day in hours, minutes, and seconds. So there are two examples here. The second example includes fractional seconds as well. The timestamp type stores both date and time together. So in the timestamp, you start with year, month, day, and then the hour, minute, second, and then fractional seconds. The interval type represents a period of time such as days, months, and months of years. Interval 1 day, you can subtract date, time, or timestamp values from each other which results in an interval. You can also add interval values to date, time, or timestamp values to get new date time values. SQL also provides ways to store large objects such as photos, videos, and large text files. These are stored using special data types called blobs or large objects. Blob is a binary large object. A blob is used to store large collections of binary data like images, videos, or CAD files. The database doesn't interpret the data in blob, it's just a raw binary data, and the application outside the database handles it. Glob is character large object. A glob is used to store large collection of character data like long document or text files. When you query a large object, the database doesn't return the entire file. Instead, it returns the pointer to the object. The application uses the pointer to access the data. SQL allows you to create user-defined types or UDTs to make your code more readable and maintainable. One way to do this is by using the create type construct, which allows you to define custom data types based on existing ones. Let's say we want to create a type for handling monetary values. We can define a custom type called dollars. So create type dollars as numeric 12 to final. Here the dollar is a user's defined type that represents a numeric value up to 12 digits and 2 decimal places. The keyword final means that no other type can be derived from dollars. Now we can use dollars type when we create a table, like create table department, department name, varchar, building varchar, and the budget is dollars. In this example, the budget column in the department table will use the dollars type we created. SQL provides the create domain construct to create user-specified domain types. Domains are similar to types, but allow you to specify constraints directly on them, such as not null or custom conditions. Here's how to create a domain for a person's name. Create domain person name, character 20, not null. In this example, person name is a domain, and we have added not null constraint to ensure that the field can never be empty. You can also add more complex constraints to domain. For example, let's say we want to define a domain for degree level to restrict it to specific values like bachelor's, master's, or doctorate. Here we create, in this example, create domain degree level. In this degree level domain, with a constraint that only allows one of these values, that is master's, bachelor's, and doctorate. The check constraints enforce that any value assigned to degree level must be either bachelor's, master's, or doctorate. Why do we use domains? You can reuse the domain definition across different tables, ensuring consistency in data types and constraints. It simplifies the schema by defining common data types and constraints in one place. When you query a database, especially large tables, it is inefficient for the system to scan through every record to find what you need. This is where indexes come in. An index is a data structure that allows the database to quickly find rows with specific values for an attribute. Instead of scanning the entire table, the system can use the index to locate the relevant records efficiently. You can create an index using create index command. So create index name on relation name. Let's say we have a table student and we frequently search for students by their last name. We can create an index on the last name column to speed up those queries. Create index IDX last name on student's last name. Now we here now we run the query like select asterisk from students where last name equals to Smith. The database will use the index to quickly find the relevant rows instead of scanning through every row in the table. Indexes allow the database to find records faster, improving query performance. They are especially useful for queries that search for specific values in large tables. Let's look how an index can improve performance on query in SQL. We have a student table defined like this, where create table student, ID, varchar, name varchar, and name is not null, department name is varchar, total credit is numeric 30, and then primary key is ID. Now let's create an index on the ID attribute. Create index student ID index on student ID. Now let's say we want to find a specific student by their ID. The query looks like this. Select asterisk from student where ID equals to 1, 2, 3, 4, 5. Without an index, the database would have to scan through all the records in the student table to find the one with ID 1, 2, 3, 4. This can be slow, especially if the table is large. With the index on ID, the database can only use the index to quickly locate the row where ID 1, 2, 3, 4, 5 is stored without scanning the entire table. This makes the query much more efficient. In SQL, we can assign different privileges or authorizations to users to control what they can and cannot do with the data in the database. Each type of privilege determines the level of access a user has. Read allows users to view data, but they cannot make any changes to it. Insert allows users to add new data, but they cannot modify or delete existing data. Update allows users to modify existing data, but they cannot delete records. And delete allows the users to remove data from the database. You can assign a user any combination of these privileges on specific parts of the database, such as table or a view. In addition to controlling access to data, SQL also provides forms of authorization that allow users to modify the database schema. These authorization determine that what changes a user can make to the structure of the database, not just the data. Forms of authorization for schema modification. Index allows users to create and delete indices on table. Indexes improve query performance, and with this privilege, a user can manage those indexes. Resource allows a user to create new tables on relations in the database. This is useful when you want to give users the ability to define new structures. Alterations allow users to add or remove attributes, columns in existing table. This is especially when the database structure needs to be updated with new fields. And drop allows users to delete relations or tables from the database. This is powerful privilege as it can remove entire tables and their data. These privileges can also be combined depending on the user's role and what access they need. For example, a database administrator might be given all schema modification privileges. In SQL, the grant statement is used to give users or roles specific privileges on relation or view. This is how we manage who can access and modify parts of the database. Grant privilege list on relation or view to user list. Privilege list, the list of privileges that you want to grant, such as select, insert, update, or delete. Relation or view, the table or view on which the privileges will be granted, and user list, the users or roles that will receive the privileges. This can include a specific user IDs like Amit and Satoshi, the keyword public, which gives the privilege to all valid users in the database. Let's say we want to give Amit and Satoshi the ability to read the department table. So grant select on department to Amit Satoshi. The grants them read access to the department table. Granting the privilege on a view does not automatically grant any privileges on the underlying tables or relation. It only affects the view itself. The grantor, the user granting privileges, must already have the privilege they are granting. If not, they must be a database administrator. In SQL, you can control access to tables and views by granting specific privileges to users. Let's go over the common types of privilege you can grant. Read access to view or read access to a table or view. It allows users to query the data but not modify it. Grant select on instructor to U1, U2, U3. Here, and to give users U1, U2, and U3 the ability to read data from the instructor table. Insert allows the users to insert new rows into the table. Grant insert on instructor to U1. This grants user U1 to insert data into instructor table. And then grant update on instructor U1 allows the user to modify rows in the table using the update statement. And finally, delete allows the user to delete rows from the table. Grant delete on instructor to U1. You can also use all privileges as a shorthand to grant all available privileges to a user. To give a user all privileges, you on the instructor table, grant all privileges on instructor to U1. Similar to how you grant privileges, you can also revoke privileges. Instead of using the grant keyword, you use the revoke keyword, and that revokes the privileges that the user have on those tables. The syntax is similar to the grant privileges. In SQL, roles are used to manage the group privileges for different users, making it easier to control what various users can access and update in a database. Create a role. You can create new role using the create role statement, which is useful for grouping privileges that apply to a specific set of users, such as all instructors. Create role, then role name. Let's say we want to create a role for all instructors. Create role instructor. Assign users to a role. Once the role is created, we can assign users to it using a grant statement. This allows you to assign the privileges associated with the role to a specific user. For example, grant role name to users. So you can say grant instructor to U1, U2. Instead of assigning privileges to each user individually, you can assign a role to multiple users. Changes made to the role automatically applies to all users associated to that role. In SQL, roles can be used not only to group privileges for users, but also to create a chain of roles that allows users and roles to inherit privileges from other roles, making it easier to manage access and permissions. So create a role and assign it to user. Create role instructor, grant instructor to Amit. Let's create a role instructor and assign it to user Amit. And then grant privileges to role. You can grant privileges directly to a role. For example, to allow the instructor role to read data from the SQL table. So grant select on takes to instructor. Now all users, you can all users assigned to the instructor role, including Amit, will inherit the select privilege on the takes table. Roles can also be granted to other roles, forming a chain of role inheritance. This means roles inherit all other privileges of other roles assigned to them. Create a new role teaching assistant and grant it to instructor. So create role teaching assistant, grant teaching assistant to instructor. Now the instructor role inherits all privileges to the teaching assistant role. We can create another role, dean, and grant the instructor role to it. Now, any users assigned to the dean role will inherit both the privileges of dean and instructor, and all other roles instructor inherits, like teaching assistant. We can assign user Satoshi to the dean role. User Satoshi now inherits the privileges from the dean, instructor, and teaching assistant roles. Let's explore what happens when users query a view and don't have permissions on the underlying table. We have created a view geo instructor that selects the data from the instructor table where department name is geology. We then granted select privileges on the view of the geo staff role. What happens when the geo staff member queries the view? If a geo staff member issues the following query, select all from geo instructor, the following scenarios can occur. Scenario 1, geo staff does not have permission on instructor. Even though geo staff role has select permissions on the view geo instructor, if the member of geo staff do not have permission on the underlying instructor table, the query will still work if the view creator or definer has access to instructor. This is because the view acts as an abstraction layer, and the permissions for the querying the underlying table are based on the definer's access, not the query executor's access. However, if the view is defined with definer's right, which is the default in most systems, then GeoStaff can access the view even if they don't have permissions on the underlying table. And then scenario 2, creator of the view does not have full permission on instructor. If the creator of the view did not have the necessary permission on the instructor table, at the time for the view was created, the view creation would fail. For example, if the view creator didn't have select permission on instructor, they wouldn't be able to create the geo instructor view in the first place. If the permissions of the view creator are revoked after the view is created, queries on the view may fail if the database system enforces owner-based access control. And there are other authorization features like grant reference, transfer or privilege, like you can grant select on department to Amit and grant option, and revoke select on department from Amit Satoshi Cascade. So this is it for this chapter. In the next videos, we will start from chapter 5. Thank you.